Here are some examples about inverse variation. Problem 1. Graph the inverse relation where y equals 3 at x equals 2. We know that in an inverse relation, there exists a constant k such that the equation xy equals k is satisfied. We can also write this equation as y equals k over x. Now to find out exactly what we're graphing, we need to figure out what k is first. Since the equation xy equals k is satisfied for all values of x and y on this curve, the values of 3 and 2 can be plugged in. 2 times 3 equals k, since y equals 3 at x equals 2. So k is equal to 6. This means the equation we want to graph is y equals 6 over x. First, let's draw the axes for this graph. These will be the y and x axes. Now let's plot some values of xy pairs in this curve so we can connect them to draw the graph. At x equals 2, y equals 3. We can put that about there. At x equals 3, y will be 6 over 3, which is 2, which is around here. At x equals 1, y will be 6. At x equals 6, y will be 1. And then we know that it'll be the same over on this side of the axes. And now we know what the shape of this curve is going to look like from previous examples. So it should look like this. And that's our graph. Let's give it a scale. Problem 2. Write an inverse variation equation that relates x and y if y is equal to 14 at x equals minus 1, and then find x when y equals 2. We know that x and y will always satisfy the equation xy equals k for a constant k. Since we know one pair of x and y values, we can calculate what k is. At x equals minus 1, y equals 14. So minus 1 times 14 equals k. So k is equal to minus 14. This means our inverse variation equation is xy equals minus 14. Next, we want to find out what x is when y equals 2. So let's plug y into this equation. X times 2 equals minus 14. So we can solve this by dividing both sides by 2. The 2 on the left side will cancel, and we're left with x equals minus 14 over 2, which is equal to minus 7. Problem 3. Write an inverse variation equation that relates x and y if y is equal to 3 at x equals 5, and then solve for y at x equals 1. The inverse variation equation will be written in the form xy equals k for some constant k. Now to find k, just like before, we'll multiply x by y. K is equal to 3 times 5, which is equal to 15, since 3 and 5 make up a point on this graph. This time, let's solve for y at x equals 1 without using k or the inverse variation equation. Instead, we can use the proportion y2 over y1 is equal to x1 over x2, when x1, y1 and x2, y2 are 2 points. Our first point is already given to us, which is 5, 3. And the second point, we know the x value is 1, but we don't know what y2 is yet. So let's plug these numbers into the proportion. We get y2 divided by y1, which is 3, equals x1, which is 5, divided by x2, which is 1. So if we cross multiply, we get 1 times y2 equals 3 times 5. Therefore, y2 is equal to 15. And that's the value we wanted.